Hi everyone, this is our second example and we're going to graph the given rational function. Let's start by identifying asymptotes of this graph. Let's determine vertical asymptotes. They can occur at values of x that make the denominator equal 0. Let's set it equal to 0 and solve the resulting equation to find such values. I isolated x squared, applied the square root, and then obtained two values, positive 4 and negative 4. These are going to be the two vertical asymptotes. Here they are. Next, let's determine the horizontal asymptote. I'm checking the degrees of the polynomials in the numerator and the denominator. The numerator is just a constant, so it's the polynomial of degree 0. The denominator has degree 2. Since the top degree is less than the bottom degree, the graph of this function will have the horizontal asymptote, and that's going to be the x-axis, which is the same as the line with equation y equals 0. Here's the asymptote. And now we want to check if our graph crosses this horizontal asymptote. For that, we're going to replace y with 0 in our function. In other words, we're going to place 0 here for f of x. To solve this equation, I'm going to multiply both sides by the denominator, x squared minus 16. This clears the denominator, and on the left I can see that I'm going to be getting 0 since I'm multiplying by 0. So as a result, I'll have 0 equals 4. In the process of solving this equation, the variable x got eliminated, and I ended up with a false statement, 0 equals 4, which means that this equation has no solution, and we conclude that the graph is not going to cross the horizontal asymptote. Next, let's check for the oblique or slant asymptote. Well, since the degree of the numerator is not one more than the degree of the denominator, the graph will not have an oblique asymptote. In the next step, step 2, we're going to find the y-intercept. For that, we plug 0 into the function, so we find f of 0. That's 4 over 0 squared minus 16, or 4 over negative 16. That's same as negative 1 over 4. So the y-intercept is the point 0, negative 1 over 4. Here I plot it on a graph. Step 3 is to find the x-intercepts, if any. For that, we have to let y be equal 0 and solve for x, this equation. But we actually already solved it, remember? When we were checking if the graph crosses the horizontal asymptote, which is the x-axis. And we found that it does not. Since the graph doesn't cross the x-axis, it means it doesn't have any x-intercepts. And that means that after finishing the first 3 steps, I only have the asymptotes in one single point. Well, of course, I will find more points in my next step, but actually what I have so far gives me the pretty good idea of how the branches of their graph will be positioned. And this is how we think about it. We know that no graph is going to cross the vertical asymptotes. Well, we also showed that our graph is not going to cross the horizontal asymptote. That means that it's going to have several different branches, each positioned inside the region surrounded by the asymptotes. And if I see the y-intercept here, it means that in this region, surrounded by asymptotes, I'm going to have the branch of the graph. I also know how graph behaves around asymptotes. Or I should say I know how the ends of the graph behave around the asymptotes. The ends of the graph always approach asymptotes, but never touch or cross them. So that means that here, in this region, I am expecting to see a branch of the graph that looks like parabola, with its ends approaching the vertical asymptotes. Well, I'll find a few more points for me to graph, maybe at negative 1, negative 3, positive 1, and positive 3. Now, what else I can predict about my graph? Well, branches of the graph can never be stacked up vertically. So if I have a branch here, I will not gonna have one over here because otherwise the graph will not pass the vertical line test. So that means that I should have more branches on the left and on the right. By finding a few more points, I will be able to see how they're positioned. Okay, so I found additional points for this portion of the graph and connected them. It's not exactly the parabola, of course, but it resembles the shape. And now I'm going to find more points on the left and on the right. I found and plotted points at more values on the left and on the right, and I can see that all those points are above the x-axis, so I will have a branch in this region here and then this region on the right. From looking at these points and also knowing that the ends of each branch will have to approach the asymptotes, I'm able to sketch each curve. Something like that. Please keep in mind that if you plotted points and those points force you to cross asymptotes when you connect them, and you know that you shouldn't cross the asymptotes, then that means that you miscalculated points, so go back and recheck your work. But for now, that's going to be the sketch of the graph of the given rational function.